Rules for naming aromatic hydrocarbons. So we're just going to stick with the smaller ones. The smallest one is benzene, so we just have to memorize that. And then we can have substituted benzenes. So a benzene ring with something on it. First we'll look at just one substituent. So generally we take the name of the substituent, here's fluorine, and that name becomes a prefix to the name benzene. So with fluorine it becomes fluorobenzene. This is chlorine, chlorobenzene. This guy up here, that's an alkyl group, that's isopropyl, and so this is isopropylbenzene. And this is ethylbenzene. Okay? There are some that have special names. We just love the special names, more things to memorize. If we have a methyl group on a benzene ring, this is not called methylbenzene. Now, if you called it methylbenzene, I'd understand what you meant, but it's silly. That's not what everybody calls it. It's called toluene. It's got a special name. So toluene is methylbenzene. We just don't call it methylbenzene. And this guy has the special name styrene. A systematic name would be vinyl, because this is the vinyl group, vinyl benzene, but we never use that name. It's always styrene. So you should memorize these two guys, styrene and toluene. Sometimes the substituent is more complicated than the benzene ring. You know, how would we name this guy as a substituent? Ew, right? Okay, so then we switch it and we say, well, let's name it like benzene is the substituent and it is attached to this other thing. Now the division about, longest chain, here we're kind of going with more complicated thing. So if this is something that we can't name easily, then we're going to call this phenyl. Why isn't it benzyl? Well, that's something else. It's phenyl. So as a group, this is named phenyl. And so this is butene, one butene, because we want to give this double bond the lowest number. So 1, 2, 3, 3 phenyl, 1 butene. Any questions? As you know, it's only going to get more complicated. What if we have two substituents? Well, we can indicate their positions with a number, and that is the more standard way. And then there's also an older system using prefixes, ortho, meta, and para. We typically draw these with one substituent at the top. And of course, they can rotate in space, but we just typically draw them with one substituent on top just because it makes it easier. So if we're numbering these guys, you would always start at one substituent and number in a way that would give them the lowest numbers. So here we would number 1, 2, 3, we would number clockwise. If we started at this one here and went the other way, we'd end up with 1,6 dichlorobenzene. So we don't want to do that. So that's 1,2 dichlorobenzene. Again, this prefix di is in there because we've got two chlorines. This one in the middle is 1,3, and this one is 1,4. Those are the three possibilities, the three isomers with two chlorines. Because if we put the chlorine over here, then we've got this guy again. So what about these ortho, meta, para things? Well, we're always going to have one at the top, and we sometimes call that the parent. and then we've got ortho would be in that position, meta would be in this position, and para would be in that position. And so one of my classes found it helpful to see that these letters spell the word pomp, like pomp and circumstance when you graduate from high school. Pomp. Because how do you remember which one's ortho, meta, and para? Well, one of them goes at the top, and then it goes around to the right, ortho, meta, para. So in this first one, which is also named 1,2-dichlorobenzene, we can say that this is ortho, because this is the parent. We've got one in the parent position and the others in the ortho. Ortho, meta, and para are only used if there's two substituents. If there's more, then we just revert to numbers. So this one here, the chlorine is in the meta position, and here it's in the para position. They're opposite. Sometimes the entire prefix is used, and sometimes just the first letter is used. Any questions about those guys? Aren't they fun? Now, what if you've got a disubstituted benzene, but one of them gives it a special name? So, when we've got a methyl group on benzene, we said that was named toluene. It had a special name. Well, we're not going to call this methylbenzene. We're going to name this as a substituted toluene. So here, bromine is the substituent on toluene. This is toluene right here. So with toluene, then that CH3, the methyl group that makes it toluene, has to be number 1. And then the bromine, either way we count it, is going to end up being on the 4th carbon. So 4-bromotoluene. I believe that could also be named para-bromotoluene, because you have 2 groups there. This guy over here is also toluene because of the CH3 group. So that makes it toluene, and that's what we're going to call number 1. And the substituent on it is an ethyl group. So this is carbon number 1, and now we would number counterclockwise, so this would be number 2, 2-ethyl toluene. Any questions? Then there's another benzene derivative that has a special name, and this is when you have 2 methyl groups on a benzene ring. It has the special name xylene. And there's 3 different isomers of xylene. There's ortho, meta, and para xylene, depending on whether those methyl groups are next to each other or across from each other or in that meta position. So this is another special guy you need to memorize. Toluene is benzene with 1 methyl group. Xylene is benzene with 2 methyl groups. When we have 3 or more substituents, then we're going to use numbers. We're not going to use ortho, meta, and para. And we're going to follow this numbering scheme that we have where we're trying to get the lowest numbers on the substituents. If you end up with 2 ways of numbering that give you the same numbers, then you're going to look to the alphabet and you're going to look for the substituent that comes first alphabetically, and you want to give that one the lowest number. So let's look at these examples here. So this guy, we're going to start numbering on one of the carbons that has a bromine. If we started over here and made this 1, 2, 3, 4, we'd end up with 1, 3, 4 tribromobenzene. This one's better because we've got 1, 2, and 4, lower numbers. So we're always going for the lowest number. The reason for that is all of these have one name one IUPAC name. Now sometimes they've also got a common name, and that's unfortunate, but what are we going to do, right? This guy over here. Here we've got 2 chlorines and 1 bromine. So no matter how we number it, we're going to end up with 135. But we want the bromine to have the number 1 because bromine comes before chlorine in the alphabet. So we're not going to call it 3-bromo-1,5-dichlorobenzene. The only way this is really going to get into your head is by doing homework, practicing. Any questions? The original slides here gave all of that 1, 2, and 3 substituents on one slide. They're like, that's just not enough information. Let's do some examples here. Assign IUPAC names, not common names, IUPAC names to the following benzene derivatives. Oh, I skipped a slide. There we go. Let's start with A. Okay, so let's look at this guy. We've got a benzene ring, and we've got a bromine on it. And what's this guy over here?
Toluene, right?
Well, there's a crick here. So this is an ethyl group on benzene. Does that have a special name? No, it doesn't. So no special name. So we've got benzene is our base name. And we've got bromine and ethyl, bromo and ethyl, and so we have to decide how to number these. Well, we should start with number 1 on bromine, right? Because that comes first alphabetically. And the short way is to number this way, 1, 2, 3. So we'll list the first alphabetical one first, 1 bromo, and then, that's an O, and 3 ethyl benzene. Does that make sense? Yeah. This is CH2. I had to make these drawings on the computer, which now I've got the hang of the program, so it'll be fine, but it just took way too long. And I was trying to make them look just like the ones in your textbook, but I couldn't always manage that. So if they look a little different, these are the examples from your textbook, but they might look a little different. Yeah, so in the textbook it actually had the CH2 written in there. This is a style, what's up here is a style where you just show the hydrogens on the terminals and not on the carbons in the middle. So maybe I'll figure out how to do that later. What about this guy down here? This next guy. Does it have a special name? We've got chlorine, and what's this guy over here? Pickles, propyl, right? So that's a propyl group, and this is chlorine, so no special name. So we've got chlorine comes first in the alphabet, so we want to give that number 1. When we count around, this is number 4. So this would be 1 chloro, 4 propyl benzene. Now, what if we used ortho, meta, para instead of the numbers? In letter A, are these two things in the ortho, meta, or para position? Well, to determine that, you have to stick one at the top. So, if we put this at the top, make this the top, P, O, M, P. So this would be meta, the meta position. And so another way we could describe this is meta bromo ethyl benzene. With meta, we don't need numbers on bromo and ethyl, because meta tells us they're separated by one carbon. And then letter B would be what position? Para, because they're opposite from each other. So that would be para chloropropyl benzene. Well, there's a couple more. Let's do those two. Okay, letter C. This is where you would use the phenyl, yeah. Because this guy, 1, 2, 3, 4, 5, 6 carbons. So that's a hexane. It'd be some sort of a hexyl group. But that's the same number of carbons as the benzene. So we're going to name the benzene as a substituent to the hexane. So we'll want to number this 1, 2, 3 to give that phenyl group the lowest number, and we're going to call this 3-phenylhexane. Three-phenylhexane. Any questions about that one? How about letter D? Well, it doesn't have a special name, right? It's not styrene or toluene. It's not xylene. So we've got 3 substituents, and we want them to have the lowest numbers. So because bromine comes first in the alphabet, we're going to give bromine the number 1. And then if we number counterclockwise, 1, 2, 3, we get 4 and 5. And if we go clockwise, we get 3 and 4. So this will be 1 bromo, 3,4 dichlorobenzene. Now the reason that some of these things have common names is because some very commonly used organic chemicals have some really long names. And so, we call them George. Question?
In the book it calls it polysubstituted, so would that be wrong?
That's a good question. 4-bromo 1,2-dichlorobenzene. Because B comes before C in the alphabet, doesn't it? Yeah, I think that's wrong. Because if you look on page 71 at the bottom, it gives the example 1-bromo 3-chlorobenzene, not 3-bromo 1-chlorobenzene. Sloppy. But thank you for asking. Yeah, I think that's wrong. Yes.
The 3-phenylhexane
Mhm.
on top.
Yeah.
I'm not so sure where that comes from.
Okay.
Because there's those 2 branches.
Yeah. And this is where we have to learn how to see what these things are. So this is one 6-carbon chain, right? and it is attached in the middle. And so it's a little hard to name. We could, let me see what the answers. What did they call it? They called it 3-phenylhexane. We could call it 3-hexylbenzene. That would be, I believe, another name for it, 3-hexylbenzene. 3-hexyl because the hexyl group is attached at carbon 3. But here we have a 6-carbon piece and a 6-carbon piece. And so it could kind of go either way.
Where does the phenol come from?
Phenyl is the prefix that we use for benzene as a substituent. Benzyl would have made more sense, wouldn't it? But it's phenyl. And your book explains that it comes from the 1800s name for benzene. Benzene used to be very widely used as an organic solvent, and people would dry clean their clothes with it. I remember reading a lot of Sherlock Holmes and Agatha Christie as a child, and you know, they're trying to get the blood out of their coat or something after they murdered someone, and they're sponging it with benzene. It's not good for you. So any questions about the nomenclature of these benzene derivatives? Physical properties, chemical properties. The physical properties, again, are going to be similar to those of the other hydrocarbons, insoluble in water, soluble in organic solvents, low densities, boiling points increase with molecular mass. Benzene itself is a colorless flammable liquid. It burns with a sooty flame. So you see a lot of black smoke when it comes. We get aromatic hydrocarbons primarily from petroleum products. And like I was just saying about Sherlock Holmes and stuff, benzene was once a very common organic solvent. But we now know that it has some pretty significant short and long-term toxic effects. And the two most common ways to be exposed to benzene currently are by inhaling gasoline vapors. There's quite a bit of benzene in gasoline. And so that's why you don't want to be inhaling the fumes when you're filling up your car. And it is all, benzene is a combustion product present in cigarette smoke, which is one of the reasons that cigarettes are really not good for you. Chemical reactions, because of that delocalized bonding, those aromatic rings are very stable. And so they're not going to undergo addition reactions because that would involve breaking up that ring. And so those don't happen. But they do undergo substitution reactions. And there's two important types we're going to talk about, alkylation and halogenation. So, yeah, alkylation is where you have an alkyl group, and that could be methyl, ethyl, isopropyl, any of those guys. An alkyl group substituting for one of the hydrogens. Now, there aren't any hydrogens drawn on this structure, but each of the carbons has a hydrogen. And so with the appropriate catalyst, we can have an alkyl halide, like ethyl chloride or something, and we can get a hydrogen to come off and put that R group on. So this is the generic way of writing that equation, and R generally stands for an alkyl group. Here's a specific example. So here we have chloroethane, or ethyl chloride, depending on which system you're using. This ethyl group can switch places, can substitute for a hydrogen on the benzene ring. And then you get ethyl benzene, and your product is hydrogen chloride. So that can happen with pretty much anything. And they're not giving examples of the halogenation. Oh, did I miss that? I missed it. Okay, so I backed up here and I'm just going to draw it for you. So halogenation is where we've got bromine or chlorine being added. Let's just do it this way. So halogenation. We talked about a substitution reaction, an addition reaction on Monday for the alkenes. Halogenation here is a substitution reaction. So you've got your benzene ring, and you're going to add a halogen. Could be bromine or chlorine. This is also going to need a catalyst. And the bromine switches places with one of the hydrogens. So we end up with a bromine on here and HBr as our product. So those are the two types of reactions. Any questions? There are also fused ring aromatic hydrocarbons. These get very large sometimes, and they're complicated and they're difficult to name. So we're going to tell you about them, but we're not going to name any of them. I'll just give you some examples. What's a fused ring? This is an example of a fused ring. This is aromatic because we've got the alternating, at least the way we draw it here, alternating double single bonds in this one and in this one. It's a fused ring structure because it shares two carbons. So these two carbons are present in both of these rings, and that's what a fused ring structure is. Over here we see that we have 3 rings fused together, and here are 3 rings fused together in a different way. And so a lot of these guys have special names. This is naphthalene. Many of these fused ring aromatic hydrocarbons are carcinogens, so they're cancer-causing agents, and so a lot of them are pretty dangerous. And I think that's the end, yay, of chapter 2.